Hi and welcome. In this video, we will introduce another polynomial function, namely linear functions. A linear function f is defined from the set of real numbers to the set of real numbers with equation y is equal to f of x equals to ax plus b, where a and b are constant numbers with a not equal to 0. That is, a is either negative or positive. For instance, y is equal to f of x is equal to 3x minus 1, or y is equal to g of x is equal to minus 2x plus 1. Remember that the most important characteristic of a linear function is that the power of the variable x is 1. To sketch the graph of a linear function, we first find the x and y intercept of the graph, and then we connect those 2 points using a straight line, and we extend the line. For instance, in order to sketch the graph of y is equal to g of x is equal to x minus 4, what we do is, of course, first of all, we consider a two-dimensional space, x and y coordinates. We let x to be 0 in order to find the y-intercept. If x is 0, we know that y is equal to minus 4. Therefore, the y-intercept is 0 and minus 4. That's somewhere here. In order to find the x-intercept, we let y to be 0. If y is 0, 2x minus 4 is 0. From here, if we solve this linear equation, we find that x is equal to 2. Therefore, the x-intercept is 2 and 0, which is somewhere here. Now, what we do is we connect these 2 points using a straight line, and we extend the line, which gives us the graph of y is equal to g of x, which is equal to 2x minus 4. We can apply a number of transformations to a linear function. For instance, if we go for y is equal to t of x minus x plus 4, and shift it 2 units downwards, we know that t of x is minus x plus 4, then minus 3, which is minus x plus 1. Let's name this function, this new child function, as p of x. Now shift p of x 6 units to the left. That's a change in the value of x. Hence y is equal to px plus 6, which is minus x plus 6, because we replace x with x plus 6 plus 1, which is from here. Multiplying this minus sign with both terms inside, we get minus x minus 6, and plus 1 we already have. Minus x and minus 6 plus 1 is minus 5. We name this new function as n of x. Now what we do is we reflect n of x with respect to y-axis. To do that, we replace x with minus x, that is y is equal to n of minus x. That is, x is replaced with minus x minus minus x. This x is replaced with minus x. Minus 5 remains the same. Minus minus is plus x minus 5. And let's name this new function as m of x. Now expand m of x by a factor of 0.5. That means we multiply the x part of m of x by 0.5. That is 0.5 x minus 5. Remember that we multiply 1/2 with the x part of the function, not with the constant part. That is, we get 0.5x minus 5, and let's call this new function as h of x and reflect it with respect to the origin. And we know that when we reflect a function with respect to the origin, we change x with minus x and multiply the function with minus 1. That is minus h of minus x. Minus outside 0.5x replaced with minus x, minus 5 is there from the constant part. Minus x with 0.5 is minus 0.5x minus 5. Then we multiply this minus sign outside with both terms inside, and we get 0.5x plus 5, which we name it as f of x. Remember that we have started with t of x. We have applied different transformations, and we got different child functions: n of x, p of x, m of x, h of x, and f of x. Consider the linear function y is equal to f of x, which is equal to minus x plus 4, and study its sign and increasing decreasing behavior. For that, let me consider a two-dimensional space and sketch the graph. As always, we find the x and y intercept, connect the 2 points and extend. We see that this is the graph of this linear function. From the graph, we can see that f of x is less than 0 when x is bigger than 4, because for all x bigger than 4, the graph of the function is below x-axis. For x equals to 4, the function intersects x-axis, therefore the function is 0 over there. F of x is positive for all x which are less than 4. For all these x values which are here at the left side of 4, the graph of the function is above x is therefore is positive. From the graph, we know that this function is decreasing. To show that algebraically, we choose two numbers such as 0 and 5. We know that 0 is less than 5, and we find f of 0, which is 4, and we find f of 5, which is -1. Compare f of 0 with f of 5. We see that f of 0 is bigger than f of 5, and if we compare this inequality with this inequality, we see that the direction of inequality changes, and that means as we increase x, the value of the function, which is y, decreases. Therefore, the function is decreasing. Next, consider two functions y is equal to f of x, which is 2x minus 1, and gx, which is minus x plus 3, and compare them. Algebraically, what we can compare the two functions, for example, f of x equal to g of x, if 2x minus 1 is equal to minus x plus 3. And solving this linear equation, we get that 3x is equal to 4. From here, x equal to 3 or 4. That means for x equal to 3 or 4, the two functions are the same. In order to find those values of x for which f of x is bigger than g of x, we let 2x minus 1 to be bigger than minus x plus 3. Solving this linear inequality, we get that x is bigger than 3 or 4. That means for x bigger than 3 or 4, f is bigger than g. For f less than g, we let 2x minus 1 to be less than minus x plus 3. Solving this linear inequality, we get that x is less than 3 or 4. Therefore, f is less than g if x is less than 3 or 4. We can compare the two functions graphically as well by sketching the graph of the two functions. To sketch the graph of y is equal to f of x, we just find the x and y intercept, and we see that the graph of the f of x is this line here. Likewise, for the function g of x, we find x and y intercept and graph the y is equal to g of x here as this red line here. And we know that the intersection point is somewhere around 3 or 4, where the two functions are the same. Remember that an intersection point, the two functions are sharing the same y value, therefore they are the same. For all values of x less than this point, we see that g, the graph of g is above the graph of f, therefore g is bigger. And for all x at the right side of this point, we see the graph of f is above the graph of g, therefore f of x is bigger. Thanks for watching and good learning.